Welcome back to the Internet of Things experience for manufacturers, the virtual event. I hope you enjoyed this morning's presentations, and I hope you've taken the opportunity to set up some private meetings and discussions using the online platform with some speakers, sponsors, and other attendees. These are great opportunities to enrich your experience with us this week. Okay, so let's keep things moving. I'm proud to introduce our next keynote speaker, Bill Bither. Bill is the co-founder and CEO of Machine Metrics. He's a software entrepreneur and co-founded Machine Metrics in 2014 to bring visibility and predictability to the manufacturing floor with its IoT platform for machines. Bill will be available for live Q&A after the second presentation of this session. So please welcome Bill Bither.
Thank you, Brad, for the introduction. So we are a team of manufacturing and software veterans that came together in 2015 to transform manufacturing. In this presentation, I'll be sharing with you how you can use machine data to drive fast value by taking you through the manufacturing analytics journey. So we have found that manufacturing equipment, machines that are worth hundreds of thousands of dollars, operate at less than 30% utilization. The opportunity for improvement in manufacturing is huge. Despite all the innovations in machines, robotics, and automation, manufacturing today is consumed by manual processes that lead to inefficiencies. And this is evident in our benchmarking report that we recently published. Of the thousands of machines that we are connected to, the average utilization rate is less than 30%, far less than what many expect. So the promise of industrial IoT is to connect your equipment and use that data to drive efficiency. This is a huge opportunity for improvement and has led to many attempts in IoT implementations in larger organizations. However, according to Cisco, many of these implementations fail, 76%. So equipment in manufacturing is diverse and difficult to connect. Some have connected their machines only to find that the data just isn't actionable. Existing IoT platforms are not specialized. Those that have been successful require outside integrators, professional services, and years of custom development and continued maintenance. We know that in order for the digital factory to reach scale and be successful, this needs to be easier. So this is why we built Machine Metrics, which is manufacturing's first industrial IoT platform that's designed specifically for machines. We make it very easy to capture and transform data from machines and make that data actionable through increased visibility, predictive analytics, and configurable workflows that automates manufacturing processes. So I'd like to take just a couple of minutes showing a video that really explains what it is that we do, and then get into some of the very specific use cases that we found to be highly valuable to our customers.
Manufacturing produces more data than any other major industry in the world, yet has been slow to adopt the digital mindset transforming industries like agriculture, banking, and healthcare. Manual data collection is time-consuming and inaccurate. Operating on gut instinct alone leads to inefficiencies and poor decision-making that affect every component of a company's operation, from significant downtime to production losses. We're in the age of Industry 4.0, and manufacturers need every edge they can get to stay competitive. Real-time, actionable data is that edge. Your machines generate hundreds of data points every millisecond, all of which tell a story of what happened in the past, what's happening now, and what will happen next. It's time you harness that data and jump-started your factory's digital transformation. Machine Metrics provides an intuitive, flexible monitoring platform that easily collects data from any piece of manufacturing equipment and transforms it into powerful, actionable insights. Why does Machine Metrics succeed where so many others have failed? The key is in our ease of use and time to value. The Machine Metrics IoT platform is easy to install and implement. You'll start visualizing data in a matter of hours. Plug-and-play edge connectivity harnesses and standardizes machine data across your entire fleet. Our intuitive, out-of-the-box apps are easy to use and drive rapid improvements in efficiency. Training is minimal. Real-time shop floor dashboards, machine production and condition monitoring, historical reporting, and automated alerts instantly enable visibility and analytics to help your team understand the big picture. Build your own apps or seamlessly connect with your current shop floor systems to easily integrate machine data across your digital factory. Machine metrics will help your team deliver the right information to the right person at the right time. Identify potential bottlenecks before they occur. Update cycle time standards in real time to improve pricing and scheduling. Detect anomalies and predict maintenance events before they cause downtime. Empower your workforce with step-by-step instructions to optimize processes. Enable lights-out manufacturing with remote monitoring and alarm notifications. With machine metrics, any manufacturer can start leveraging their machine data immediately to drive improvements and provide the foundation for scaling data across their operations. It's time to start transforming your factory, all with the click of a button. Harness the power of machine data so it can become your competitive advantage.
So over the past 5 years, we've connected to thousands of machines across hundreds of customers worldwide in discrete manufacturing industries. Industries such as medical device manufacturing, automotive, aerospace and defense, oil and gas, and heavy industry. We have focus in metal manufacturing such as precision metalworking and metal fabrication. This has been our beachhead market and where we've really got started. So I want to talk a bit about the architecture of an industrial IoT platform, and in particular, how machine metrics works. So it is uncommon for manufacturers to have a data historian that includes all the data one needs to drive value. So our edge platform can be used to connect to any machine. Most of our customers install machine metrics themselves without any assistance from us. Data is collected directly from the machine's control for modern equipment, or additional sensors can be connected to our edge device to connect legacy equipment. We automatically transform this data into standard data structures using our AI-driven transformation engine so that data can be scaled across many machines. This data can be collected at high frequencies. This allows data scientists to develop custom predictive algorithms that can be deployed back to the edge and managed at scale. So once the data is collected, it's streamed into the Machine Metrics IoT cloud infrastructure. This infrastructure is designed specifically for machines and a high volume of diagnostic and sensor data that's associated with machines. Operational data is layered on top of machine data to add additional context. Not only do we know the machine conditions, but if the machine is in setup, down for maintenance, and the part numbers that are being produced. The machine and operational data is directly accessible to software developers and data scientists through our APIs and can be visualized through out-of-the-box applications or custom integrations. Patterns in this data generate insights that initiate actions through no-code configurable workflow triggers. These triggers can send notifications or initiate entirely new processes, including those built into machine metrics that are designed to optimize the operation of the machine. Out-of-the-box applications drive value immediately after connecting your equipment. Examples of these applications include an operator interface to solicit feedback from operators and present prescriptive instructions during downtime events. Custom factory applications and integrations into other factory systems built by our customers and partners provide additional value from the machine data. Our customers have used machine metrics to digitize their factories and improve their operations. And they can build on top of this platform and build whatever applications that they feel could be leveraged using that machine data. So here's an example of what an installation of machine metrics looks like. It's inside the electrical cabinet of the machine, and it's really the first step in our manufacturing analytics journey. You have to collect the data to capture the data from the machine, and then transform that into usable data. So what you see here is that green box, which is our edge device. It pulls data directly from the machine's control or PLC. You can also add additional sensors, so that digital I/O device that's circled, that's connected to relays and sensors, and it can augment that machine data. This edge device is built for security, so it separates the machine network from the internet, and then streams that transformed data through either cellular, through Wi-Fi, or through a hardwired connection. So this after the data is processed and transformed into a standard protocol, we use MT-Connect. We can relate this machine data with another one that's very similar, and that transformed data is streamed to the Machine Metrics Cloud. The installation takes just around 20 minutes, and software on this edge device can be updated remotely through an over-the-air update to ensure timely security updates. So this is where I really want to introduce the manufacturing analytics journey. We talked about the first step really is in capturing that data and transforming it, but without the analytics, you really aren't really seeing the value yet. So there's 4 steps to this journey. Typically we start with descriptive analytics. This is where data can tell you what is happening on your factory floor. It's the dashboards and reports that provide this data. And there's a lot of value to be found just improving visibility. And it's really the simplest and fastest first step to take. And going a little bit deeper, it's really about diagnostic analytics. This is what helps you understand why the machine is down or why this current or past behavior has occurred. More advanced diagnostic tools can lead to answering these questions to identify bottlenecks, so corrective action can be applied to the right problem. So the next step really is predictive analytics. This is what tells you what's likely to happen based on past patterns and events. We have seen predictive applications in continuous rotating machinery and process manufacturing, but predictive has been quite elusive in discrete manufacturing due to all the changeovers that occur. And then finally is prescriptive analytics. This is really what informs the user about what steps should be taken to prevent future problems from occurring. Use cases that support both predictive and prescriptive analytics are really considered the holy grail for manufacturing, as it cuts out manual processes and continuously closes the loop on the data in real time. So further to these 4 steps in analytics, we have to ensure that the data is used to actually take action. And that's where each step along this journey, if you configure alerts and notifications that really hold the users accountable to this data and the processes that are changed from this data, this is where that real value is achieved. So I'm going to talk a few minutes about some of the use cases that we have found to be very valuable amongst our customers in leveraging this machine data. And these first few use cases are around using that data for descriptive analytics. And here you can see there's a dashboard that displays all of your machine data and in front of all of the the factory workers. And you also have an operator interface that's above the operator's head. You can see in the photo here. And this machine data, it isn't just about displaying the status of the machine. It's about really tying that to the goals that are meant to achieve so that everyone can be on the same page and you really have a transparent operation. Just by having this information visible, we've seen our customers improve their productivity by as much as 20%. And there's a simple example that one of our first customers shared with us when we first started Machine Metrics about 5 years ago. And that was that they had a machine that produced about 12 parts per hour. And but they couldn't figure out why at the end of the day, they always produced 20% less parts than they should have, that was expected. And it wasn't until they actually started measuring this data, they installed Machine Metrics, that they identified that the first hour of the day, so 6 a.m., operator would come in and there would be 0 parts produced. Second hour, there was about 6 parts produced. And then the third hour, they produced 12 parts and it was pretty continuous. And what was happening, and it was really not anybody's fault, it was just a behavior. The operator would grab their cup of coffee, they'd clean up their workstation, they'd start the machine, but there really wasn't the I guess that visibility into what impact that had on the overall business. So by installing Machine Metrics and including a dashboard, the behavior immediately changed without even a conversation with that operator. So you could immediately see that your productivity was falling behind. So after Machine Metrics, the operator would come in, start up the machine, get it running, grab their cup of coffee, chat with their colleagues, clean up their work area, and immediately improve productivity by about 20%. And this is really that low-hanging fruit when it comes to machine data and IoT. It's really in just improving visibility, and so many operations haven't even taken that first step. So the other thing that this allows organizations to do is really to kind of gamify their job. And this especially resonates with the younger generation of factory workers. So if you, it really instills like a friendly sense of competition. So if one machine is performing at 80%, another one's at 100%, there's a sense of accomplishment that one receives. We've even had people, our customers, that will post to Facebook or Twitter, a photo of their performance of their dashboard, their cell of machines. It's a good day. We're all in the green. So this really has a pretty significant impact across the manufacturer, and really isn't that hard to achieve once you have the data. So, and then finally, one of the things that you could do to really sort of close that loop is to set up these notifications that we discussed. So by alerting a supervisor when unplanned downtime events occur, this could be configured, say 10 minutes, or maybe it's even an hour. What that does is that lets the operator know that, well, my boss is going to get a notification if I don't bring this machine back up and running. So it can really be helpful in terms of keeping those machines running and increasing your utilization. So the next use case that we commonly see really is around identifying the true cycle times. Often what we see is that cycle times, like when a part is designed, you have a particular amount of time that it takes to create that part. Say it's 5 minutes. But once that machine or that part is actually being produced, you'll find that an operator or programmer needs to make a tweak to the program. This particular cut needs to run a little bit slower, or we need to add a dwell. And what happens is that 5 minutes can turn into 7 minutes, and the loop is not often closed. So that ERP contains that cycle time data that's used for quoting, but you can often be actually producing these parts and quoting these parts that are going to be running with minimal profit. So by having the actual cycle times and feeding that back to your ERP, you can improve your profitability and really just improve the data that you have for planning your jobs, and you can ensure that you're not going to be delivering your parts late. So it really helps in your on-time delivery. And further, you can set up notifications so that when your cycle times change, you can notify the programmer or the supervisor to know that something is different here. And then if you want to go a little bit deeper, building the integration with an ERP means that you can automate that process, cut that manual process out from updating your cycle time standards. So this next use case is a more advanced use case of descriptive analytics. This is really around industry benchmarking. So Machine Metrics has the advantage of connecting to hundreds of plants, thousands of machines, and we're able to aggregate that data anonymously to be able to identify what your benchmark really is. How are our customers utilizing their equipment? We publish a report every quarter that's really the state of the industry report. And that's where earlier in this presentation we identified that last year's average machine utilization was just 28.7%. But what we're able to do is that we can actually feed that data back to our customers so that our customers know, depending on the types of equipment that they run, how they fare compared to their peers, other companies that are running a similar equipment. And this really helps our customers make some pretty big decisions. We had a customer in the medical device industry that found themselves in the top 10th percentile of all Machine Metrics customers, but they outsourced a lot of their work. So one of the things that they did is they decided that it's likely that their operations are more efficient than their suppliers, so they brought in their supply stream, and were able to save millions of dollars just based on that information. And on the contrary, we have customers that are in the bottom percentile. If you're in the bottom 50th percentile, for example, why are you buying new equipment? Utilize your existing equipment better. I mean, if you know that your peers are able to utilize similar equipment at a higher percentile, it's likely that you don't have to invest too much into improving your own efficiency. So that could save purchasing equipment that costs hundreds of thousands of dollars. You can take that investment, a percentage of that investment, and apply that to your own operations and become more efficient. So our customers today are making pretty big decisions based on this benchmarking data. So let's get into diagnostic analytics. So this is not that different from descriptive, only in that deeper tools, if you really can access that data a detailed level, you're able to surface why problems have occurred. So what you see here is a diagnostic timeline. It displays in detail, every second what that machine was performing, and you can go back in time. So an example of this is we had a customer that during the third shift, the machine crashed, and the operator was inexperienced, didn't really know why, and that machine was down until the next day. The supervisor was able to look at this data and identify that the program was edited. And after that program was edited, the machine crashed. And this information was being captured. By looking at that data, it was quickly revealed that that program needed to be changed back to what it was, and that that's what caused the crash. And then that step could be, I really identified that there's a training issue amongst their operators. So a course of action that could be taken in a case like this is to send out an alert when that program is edited. What that does is that can, even if your machine is running on, say, a second or third shift, this could be a trigger to contact that operator and find out what's going wrong, and really an attempt to prevent that crash to begin with. And there's scores of other use cases around diagnostics. For example, you can also identify your bottlenecks. If you track your downtime events, you can identify where your bottlenecks are occurring. You can see if you have a line of machines, single piece flow, it might be just one machine that's causing that bottleneck, which causes a reduction in utilization across a whole cell of machines. And it's really diving into that data that helps you identify why these problems are occurring. So I'd like to spend a few minutes on predictive analytics. There's, like I said before, there's a lot of applications around predictive analytics that have typically live in process manufacturing, really where there's this continuous operation of equipment. The challenge in discrete manufacturing is that often, well, one, these discrete machines have many other subsystems, and it's pretty complicated to build out predictive analytics for all these different subsystems. It also is very common to change over jobs. So you might be running one type of part, one material, one day, and you might be running a different part, a different material the next day, especially the case for contract manufacturers. So what we've been able to do is leverage high frequency data from the machine's control. And you can see an example in this the screen in the upper right, where every part that you see, there's a pattern, or it might be one cut, right, or one operation. You can see a pattern. And if you're pulling that data at very high frequency, you can identify when these patterns start to change. Now, if you look at this screen, you can see about halfway through, or in the second line, you can start to see some changes. And this pattern can be identified, and we can send an alert to indicate that that it looks like there might be an impending failure. Now, in order to really do a great job to not send out false positives, we do need to run this in scenarios that failures have actually occurred and train our models. But once we've been able to do that, we can very consistently, and we have cases where with 99% confidence, we can identify failure modes. And this is leveraging that high frequency data. And what that allows you to do is predict, for example, in the machine tool industry, we can detect a tool failure. I think in one case, there was about an hour before the actual failure. And what we can do is that when we identify that this is that the cutting tool has a problem, it's going to produce bad quality parts. By identifying this when it occurs, you eliminate that hour of machining time that is producing bad parts. And in this case, we were able to put the machine in a feed hold, notify the operator, and prevent those bad parts from being produced so that tool could be changed. And this is also the case for throwing out bad cutting tools. For example, we often, our customers, again, in the CNC machine tool industry, they're throwing out cutting tools when they have half their life remaining. And really that's because there's prior to this, there's really no way to really identify if that cutting tool is going to fail. you have all these nuances in the material being fed into the machine, into the mechanics of the tool. So there's variability there. So you end up throwing these cutting tools out when there's a considerable amount of life left. By looking at this data, you can actually run these cutting tools to almost full life before they're replaced. And this can really save a lot of your cutting tool costs, especially if you're working in harder materials. And again, we'll operate the operators on when to change that cutting tool, and this instills confidence that that tool will be able to will be able to be run throughout the full life. So the next, I guess I call it the final stage of the analytics journey, really is prescriptive analytics. And there's really an endless amount of use cases here. I like to call this like the taking the Uber model of instructing the factory workers and what steps need to be taken next to be more efficient. When an Uber driver is driving a customer, the application itself informs them where they need to go, who they need to pick up, how long the drive is going to take, and this really pulls all of the analytics together: descriptive, diagnostic, predictive, and provides these instructions to the operator. Like I said, I think if you combine all these together, predictive and prescriptive, it is really the holy grail of manufacturing. And we've just been able to start offering this to our customers through our operator interface, where we can actually present these instructions. So an example I mentioned before and really applies to prescriptive analytics is identifying when cycle times change. So if you see that your part cycle times become longer, it's often not identified for days, sometimes weeks, that this is a problem. So by letting the operator know not just that your cycle time changed, but what actually changed to cause that longer cycle time, this provides those instructions to the operator to make those changes pretty much in real time without needing their supervisor or their manager to really get involved. And this is about surfacing the right data and the right set of instructions to that operator. There's some other use cases around this, some simple ones like when the machine undergoes downtime, there is an alarm that occurs, and that alarm is indicative of a maintenance problem. And if you have instructions that go along with that maintenance problem, you can give the operator those instructions so that they can go through those steps without having to wait for the next day, maybe a maintenance technician to come in. And these are, there's many use cases around this that can be applied. A lot of this does require content to be developed. And there's also some companies that have focused just in prescriptive analytics that we can tie into. So in this really gets into what we consider the factory stack. So the days of a single system to control all factory systems are starting to be behind us. Customers that have implemented a single ERP system to really manage all of their operations, accounting, their manufacturing processes, they're very expensive, they're large, they require a lot of custom development, and really are not flexible to changing business processes. The first phase of Industrial 4.0 has really seen a lot of these systems being extended beyond what they're really designed for. IoT requires a large amount of data, and this is necessary for digitization. What I see is that the second wave of Industrial 4.0 is about leveraging third-party software systems that are more specialized. They go very deeper in their functionality and require very little customization. We have seen this in other industries, such as IT, banking, healthcare. And really, I see this as our time to really take the best of breed approach to the factory stack. It's really our time for manufacturing. And we're moving away from these behemoth ERP systems and really connecting these best of breed systems. Machine metrics is that machine data component of the digital factory. And we connect to other systems such as maintenance, quality, so CAM system, being able to really close the loop, work instructions, ERP, business intelligence. And with this, manufacturers have the freedom to choose which system is best designed for them. spend less money developing a customized solution when you have an out-of-the-box solution that can be configured and connected to others to really solve that problem and solve that problem much better. And what you end up with is more advanced capabilities that you really couldn't build yourselves. So when you put this all together, really you're building out the digital thread for manufacturing. And it really starts with capturing data from your equipment, transforming that data, applying analytics to that data, driving action from that data, and then enabling other systems and processes with that data. And this is really what I consider the digital thread. It's the digital thread of manufacturing is about connecting digital information through product design, manufacturing, inspection processes, all around making the product. But it's also about connecting data from your OEMs, your equipment providers, to your supply stream, and really the consumers of your products. And this digitization really enables new processes and business models, more automation and efficiency. Layering custom services on top of this really is what provides that value that's unique to you as a manufacturer. This is what provides that differentiation that will allow you to be competitive in the age of manufacturing. So I'd like to talk a little bit about how some of our customers have really leveraged machine metrics. Here's an example of our customer Altec. Okay, we have some customers they're in different stages of the analytics journey. Many have experienced dramatic increases in their machine utilization and productivity. Now, Altec, they're a world leader in bucket trucks serving electrical utility and telecom. You might see their vehicles when you're driving by and you see a power line being repaired. Altec started with a very small installation at one of their plants. I think they connected about 20 machines, and they were able to install completely themselves. They were able to see immediate value from those machines that they connected just by viewing the utilization and just those initial descriptive use cases. And because the connectivity was so simple, within 4 months, they had connected hundreds of machines across 9 plants. The type of equipment that they've connected include lasers, presses, stamps, welders, paint booths, and CNC equipment. And they experienced value pretty much immediately, like I said, in those first few use cases by focusing on their utilization, their reporting, and they were even able to identify where they had some plants with additional capacity. They were able to manufacture parts that they weren't even manufacturing before and then ship them to the plant that had these bottlenecks. By combining all this together, they were able to increase their equipment utilization by 15% across all their plants. And really, it's the ease of connectivity, connecting this equipment, that's enabled them to see this value across their entire organization within just a few months from their first installation. And we've seen this rapid value expansion really occur across many of our customers. And really, it's about making it very easy to capture and transform that data, and then just pick these use cases that really make a lot of sense, starting with the simple ones and then moving towards the more advanced. So I really want you all to just take a few things away from this presentation. There are certain qualities that make a successful IoT implementation. The first one really is to ensure that you have that internal champion. Who is it on your team that's responsible for the success of this project? That is critically important. When we have a champion, we see that value attained very, very quickly. The second is don't reinvent the wheel. Leverage third-party systems when it makes sense. What we're seeing is that there's a lot more maturity to industrial IoT, more products that are available that can really fit your needs. And I can't tell you how many times I see manufacturers that will start to build their own IoT solution, but then we see in a year or two that they spent sometimes millions of dollars, and they only have the start. They only have some of the data being captured, some of the analytics, and that's when it's realized that this is actually a pretty hard problem. There's other companies that are doing this, and that transition to a third party often occurs. So the other is making sure that you have the ability to connect your equipment. It's always harder than it seems, and many projects get stuck here. You have many different types of machines across your factory floor. Each one requires a certain amount of knowledge about it. So work with the companies that have experience with connecting this equipment and doing this easily, because if you get stuck in building all these connectors or different machine types, your project is likely not able to see value for quite some time. And then next really is to start small. Walk before you run. Start with the low-hanging fruit. So many of our customers want us to go right to predictive analytics, and we tell them that there's so much value just in displaying this data that you should really start there. And finally, it's more than just the dashboards, right? That's one use case of visibility. You really want to be able to take action. You want to optimize your business processes, use notifications and integrations to really provide that full value. And so that's really what we've learned in being in this industry for more than 5 years and working with so many customers. I really do hope that this presentation was helpful to you. We've helped so many customers really see value through their Industrial 4.0 and IoT initiatives, digitize their operations and scale their businesses. Really, we're just getting started. There's so much more that we're building out and that we're able to do. Please reach out to me if you have any questions. And really, I thank you for taking the time to be here at this conference and to learn all about industrial IoT. Thank you very much.